Okay, a little short lecture here. Right, the chemical reactions showing the preparation of alcohols from aldehydes. And an aldehyde has a functional group that looks like this. So there's the general form, and then you can pick a particular one like this. And you can draw it like this as well. A lot of times you put the hydrogen on there just so that you can tell immediately what you're looking at. But didn't save myself much room, so let's do this. Now, so if you have this aldehyde, it reacts with hydrogen, and what we need is a catalyst to cause this to occur. And the hydrogen, I'm going to write it as the diatomic molecule, so you can see the hydrogens. One hydrogen attaches to the oxygen, one attaches to the carbon. And so this hydrogen produces the alcohol, or the OH group I should say, making it an alcohol, and then the other hydrogen comes over here. And what we're doing is we're just adding, it's an addition reaction across that double bond. We've done that before with CC double bond. Now it's a CO. So the product would be an OH group above, a hydrogen, and then another hydrogen. So that's when the functional group is on the end, that carbonyl group is on the end, we end up with a primary alcohol, and we're going to talk about that in a second, primary, secondary, and tertiary. Now, a ketone is different from an aldehyde, that it doesn't end with a hydrogen on one side, it just has a continuation of the chain. So we can draw something like this. And we have the ketone, the double bond is off of this third carbon. And if we react it with hydrogen, and there again needs to be a catalyst. And if I had this on the exam, I'd show you this much, and then you'd have to finish it up. And it'd just be adding hydrogen across a double bond like we've done for alkenes, so it shouldn't be too bad. And then you'd just have OH. And you can also put the other hydrogen on here, just to show that they both added to that same carbon. But there's no problem if you just did this to finish up. Now, I've already spilled beans on the primary, I've used the term primary alcohol. And what that means is that the OH group is attached to a carbon that's attached to only one other carbon, and the others are hydrogens, generally. So you can have this. So we're not, the oxygen on the hydroxyl group can only attach to one carbon. So it's not about how many carbons the oxygen can bond to. It can only bond to one. But then the primary and secondary and tertiary look at what this carbon is then bonded to. There's only one carbon, so this is primary. We can also, an OH group bonds to a carbon that's bonded to two carbons. Like that. Make sure you have 4 bonds to each carbon. So this is secondary. And so we can just go back up to the top here. Let's make this one more carbon long so that we can write there's the line angle formula. And then for this one, like that, you can see that the oxygen here is on the end, here it's in the center. Then tertiary, let's see, so we have OH bonds to a carbon, which is bonded to 3 carbons. Something like this. And then we'd, the line angle drawing, we'd draw like this. And so, we use the 3-degree sign to indicate that it's tertiary.